Welcome to the National Press Club for our announcement of plans for the first private robotic mission to Mars. My name is Linda Billings. I'm Director of Science Communication with the Center for Integrative STEM Education at the National Institute of Aerospace. I do communication research for NASA science programs, and I'm here to moderate today. And I'll start by introducing our speakers. First, I should mention I'm really pleased that we actually have people in our audience at the Press Club today. It's very beautiful out the windows of the top floor of the building watching the snow fall down, but for those of you online who aren't in the DC area, the federal government is closed, meaning that Washington is basically shut down. Schools are closed, but a few brave souls have showed up and will proceed. And I know we have a lot of people watching the webcast online, so I'm looking forward to lively discussion. I'll introduce people from my left, your right. First is Bas Lansdorp. He's co-founder and CEO of Mars One. He is a self-described born entrepreneur who has a personal dream of seeing humans land on Mars, and that's what Mars One is all about, and he'll tell you about that in a minute. We also have Ed Sedivy, who's Chief Engineer for Civil Space with Lockheed Martin Space Systems in Denver, and he's here to talk about technical aspects of the mission. And I should mention also that among the many, many space projects that Ed has worked on over his career, which is even longer than mine, and I've been in the space business for more than 30 years, one of his missions was the Phoenix mission to Mars. And you'll learn why that's significant in a minute. To his left is Suzanne Flinkenflögel, who's Director of Communications for Mars One. But in between Ed and Suzanne, we are going to hear from Sir Martin Sweeting. He's with us virtually from the UK. And Sir Martin is Executive Chairman of Surrey Satellite Technology Limited, known as SSTL, and the Director of Surrey Space Center. And those of you who have been paying attention to the space business for any length of time will know that SSTL and Sir Martin are famous for innovation on a small scale and a low cost, and for his accomplishments as an innovator. And I would describe, just looking at his bio, I would describe Sir Martin as the epitome of an innovator. He's been knighted by the Queen in 2002. I'm going to turn things over to Bas, and he will turn things over to his successor, and when we're all finished with our remarks, we'll take questions. Thanks.
Thank you, Linda, and a very warm welcome to everybody here in the room, and of course a very warm welcome to everybody who's here online. Thanks for joining us. We are very excited to announce today that we have contracted lead suppliers for our first robotic mission to Mars. Lockheed Martin will build our first Mars lander, and Surrey Satellite Technology Limited will build our first communication satellite. And these missions are the first step in Mars One's overall plan of establishing a permanent human settlement on Mars. The Mars lander and the Mars communication satellite will fly in 2018, 2 years later than our original schedule. And in this new schedule, all the missions, including the manned mission, will fly 2 years later, which means that our first humans will land in 2025. And this new schedule allows for time to development of the two spacecraft, for finding subcontractors for the experiments that we will fly on the spacecraft, and to organize a number of competitions that Mars One wants to implement around these first missions to Mars in 2018. The communication satellite that Surrey will develop for us will be the first Mars synchronous communication satellite, and it will function as a data relay from the surface of Mars to Earth. It will be in a fixed location over the Mars lander, which will allow a live video feed from the surface of Mars to Earth. And we expect that this will bring Earth a lot closer to everybody on Earth. So anyone here on Earth can log in to our website and see what's it like on Mars. Is there snow on Mars? the communication satellite is nice to have in combination with the unmanned lander that we have now, but it's crucial for our manned missions, because then we really need to have that 24/7 connection between Earth and Mars. The 2018 lander will be a technology demonstrator. It will be based on the very successful 2007 NASA Phoenix mission, which Linda already mentioned. It will even have a Phoenix-like robotic arm that can scoop up soil. It will carry a camera that will shoot continuous video, and we can use it in combination with the communication satellite for a live feed of Mars here on Earth during the Martian day only. It will carry a water experiment that will demonstrate the production of liquid water on the surface of Mars. So there will be liquid water on Mars, finally, we will know it for sure. And it will carry a power experiment that will deploy a thin film solar panel on the surface of Mars. We make use of thin film solar panels for our human mission, and this will be the demonstrator of that. And we will test how a thin film solar panel operates on the surface of Mars. Mars One will send out calls for proposals for the water experiment and the power experiment in the first half of 2014, and we invite space organizations or universities or other institutions from all over the world to submit their proposals for these experiments. The Mars lander will also be used to carry the winners of a number of experiments. We will organize a worldwide university challenge where teams from universities can propose experiments that will actually fly to Mars on our lander. Well, at least the winner will fly to Mars on our lander. And if you look at how exciting students already are about sending a little CubeSat to Earth orbit, you can imagine how exciting this will be for engineering students to work on. We will also organize a number of science, technology, engineering, and mathematics challenges, probably two. So STEM challenges. There will be separate challenges for younger and older students. The older students, 14 years and older, will be able to propose experiments, much like the university students. And for younger students, we will send some kind of item to Mars. We haven't fully decided on that yet, but we want to have winners from many different countries to really inspire kids into Mars exploration. And this is very important for Mars One, because with these challenges on our unmanned mission, we can inspire young students even before we send humans to Mars, which will, of course, be an even bigger source of inspiration here on Earth. Well, Mars One is in very serious discussion with a number of major companies for partnerships around our 2018 mission. Examples are companies that are interested to be partner in the university competition. Those are companies that are very interested in being in touch with good engineering students from all over the world and using our competition to actually get to them and get their name in those communities. And companies interested to partner on the STEM challenges, because a lot of companies, especially in the what we call the Western world, are very anxious to make sure that there are actually still engineers 20 years from now. And we're also in contact with a number of partners who are interested in using our 2018 lander for very exciting and very exclusive PR events. These partnerships will contribute very significantly to the cost of the overall 2018 missions. And in combination with the contracts that we announced today with Lockheed Martin and Surrey, we believe that we are in very good shape to make this happen. I will now pass on the word to Ed, who will give you more details on the 2018 lander.
Okay, welcome. Thanks for coming. Lockheed Martin is very, very pleased that Mars One has asked us to study the mission concepts for the 2018 orbiter and lander. So we've already been working on that for a number of weeks. We have a team of engineers who are currently involved with flying 3 Mars orbiters. There's 2 that are in orbit around Mars, and then there's the MAVEN orbiter that launched a few weeks ago. and we have a Mars lander, the InSight lander, that's in development right now for a 2016 launch. So that team of engineers, we have the opportunity to draw on selectively to support the study. So over the next 3 to 4 months, we'll be looking over the mission concepts, the launch opportunity that 2018 presents us to fly from Earth to Mars, how best to stack a launch vehicle with a orbiter and a lander, the payload suite that Boz has outlined with the robotic arm, a camera, water experiment, thin film solar arrays, the student challenge results, and that collectively defines a suite of payload capability that we need to make sure that the lander can provide. So we want to make sure there's enough flexibility in the way that we scope the payload capability to allow Mars One to lead that student competition and select meaningful payloads and science experiments, technology demonstrations to take to the surface. All right, so it's a great opportunity. We're really excited about a few aspects of this mission. First of all, it is the first privately funded planetary exploration mission. If you think about that, that is really, really cool. You know, so the opportunity to participate in that is just really exciting. So one way that we view this is the dawn of a new era of space exploration. Private funding that supports exploration of other planets is a concept that is just really exciting. Second aspect that we're really excited about is the opportunity to partner with international companies and the Mars One Foundation, Surrey Satellite Technology, and then the supplier chain that we typically deal with. So international collaboration is increasingly growing in importance, and really the collective ability of us to partner across oceans and across countries is going to be key to our ability to explore. And then the third aspect that's so exciting is the STEM engagement. I'm an engineer. I love what I do. It's a lot of fun. I've had a wonderful time working planetary exploration, and the opportunity to engage students all across the world and get them fired up about exploring and Mars and putting payloads on the surface and the eventual opportunities that bridges to is just very, very exciting. So with that, what I'd like to do is turn it over to Sir Martin Sweeting of Surrey Satellite Technology and ask him to talk to us about the orbiter.
We're actually just as excited as our colleagues at Lockheed Martin. This has been a dream for us at Surrey for many years. Surrey has specialized over the last nearly 3 decades on changing the economics of space, and particularly in using small satellite techniques to really revolutionize the access to space. We've done this over some 41 missions, which we designed, built, and launched here at Surrey. And that includes the first of the European Galileo Communications Navigation Satellite, GOVA, which was launched about 8 years ago now. And our proposals and the study that we're going to be carrying out for Mars One on the communications orbiter is going to be based on the technology which started out with GOVA and is now being used on the 22 spacecraft that we're building together with our compatriots in Germany for the European Galileo navigation system. So we will be drawing on all that experience to provide a really capable but low-cost solution to providing communications in real time from Mars orbit. I mean, Surrey has been interested in driving the cost of exploration down and also increasing the tempo of exploration and widening participation for many years, and we've been doing work in the past on projects to look at supporting sustained human habitation on the moon, for example. And so the Mars One is really a logical step for us and something that we find really exciting in trying to develop. You see beside me a model of the geostationary communications spacecraft that we're currently developing, which has been supported by the European Space Agency. And together with the experience we have on the Galileo system, this is going to provide the key to the Mars orbiter. So we're really excited here at the company because this is something that's been part of our long-term dream for many years, and for me personally, it's what it's all about. And alongside the company, we of course have the Surrey Space Centre, which is an academic team of about 100 people, and they are stimulating and driving the interests of young people, young researchers, but also beyond that out into the schools environment as well. So the whole concept of Mars One fits really very closely with our interests and our capabilities. So we're really looking forward to working with our colleagues at Lockheed Martin and Mars One to make this reality, and very soon.
Thank you. We would like to invite everybody around the world to participate in this mission. So, as Bas has already mentioned, we'll be organizing 2 STEM challenges and a university experiment challenge in 2014. For the STEM challenges, we're still discussing details with several potential STEM partners, but university students will be able to send in a proposal for a experiment, and high school students will probably do the same. And then for students under 14, they will probably be able to send, for example, a hard copy letter to the surface of Mars, and it will wait there for the future astronauts. Then earlier today, we launched a Indiegogo crowdfunding campaign, which you can already find online. It will help us fund part of this mission, but also it will show our partner sponsors and investors that this is something that actually the whole world wants to happen and wants to contribute to. But most importantly, it's a great way to give people the opportunity to participate in this mission and actually contribute to it. So all contributors will be, for example, granted voting rights for some decisions up for vote in the future, including the winners of the STEM and university challenges. Later today at 1:30 p.m. EST, there will be a tweet up, and everybody can participate by logging into Twitter and use the hashtag #AskMars1. So please ask your questions there, and we'll be happy to answer some of them. And then now we would like to show you our Indiegogo introduction video. Thank you.
For hundreds of years, humanity could only dream of visiting and ultimately living on another planet. Mars One is a daring initiative by people with vision and imagination. This project seems to me to be a great way to fulfill dreams of mankind's expansion into space.
I remember playing with my space Legos as a child, dreaming of the day the first astronaut would step on another planet. I have wanted to go to Mars for as long as I can remember. Arno and I started Mars One because this dream is still alive within us. We want to step out of the hatch and experience a new frontier, to pick up rocks that have never been picked up before. If you dream of the day that humans walk on another planet, this is your chance to be part of mankind's first mission to Mars.
The goal of Mars One is the permanent settlement of Mars, beginning with a 4-person crew in 2025, followed by additional crews arriving every 2 years. We are blessed to have in our team top scientists, suppliers and leaders, and we're prepared to make this mission reality.
We are all explorers. Our mission is empowering scientists, adventurists and explorers to live this dream. We're breaking down barriers by enabling everyone, including you, to participate in space exploration. This can be your mission to Mars.
In this Indiegogo campaign, we ask for your help in the first ever private mission to Mars, and our first step in establishing a human outpost there. This campaign will pay for the technology studies for our first unmanned mission in 2018, which will demonstrate hardware for the human mission in 2025. The lander we sent to Mars in 2018 will be built by Lockheed Martin, a worldwide leader in aerospace technology and the organization that provided much of the critical technology for the past NASA missions to Mars.
The 2018 robotic lander mission we're studying for Mars One will utilize much of the proven design of NASA's successful Phoenix lander. This is going to be the first private mission to Mars. Lockheed Martin is very excited to have been contracted by Mars One to conduct a mission concept study for such an ambitious project. Having been the spacecraft manager on the Phoenix mission, I can tell you landing on Mars is a challenge and a thrill, and this is going to be a really exciting mission.
Our lander is not big enough to bring everyone to Mars, but we do promise you a front row seat. By supporting our campaign, you can attend our 2018 spacecraft launch or virtually travel to Mars with your own Mars selfie, a personalized photo from Mars. And how about a small replica of the Mars One lander to show off to your friends? Or perhaps you'd like to have your name printed on the landing parachute. We are providing you some absolutely amazing options to join our campaign. We can't wait for you to join us and be part of the most exciting event in the history of humankind.
So please contribute to our mission to Mars. Let's take charge of manned space exploration. Mars One will inspire our children and all future generations. And you have the opportunity to take part in this historic mission. This is the next giant leap for mankind. Your contribution, large or small, will help turn this dream into reality. Thank you for making this happen.
So I will wrap up for our statements. As you can tell from all the statements here, everybody is really excited. Mars One is very excited. We have 200,000 applicants for our manned mission that are very excited. One is actually here in the audience. Two, sorry. Our suppliers are really excited, and even we have a Nobel Prize laureate who is really excited about this. So a lot of people want this to happen. But what's very important, you can't go to Mars on excitement. So what we have noticed is that ever since we've been talking about this first unmanned mission with using existing technology, a Phoenix-based lander and a Mars communication satellite based on existing technology, this low-risk approach makes it much easier for us to get in touch with very interested partners. And it makes our plan lower risk, and they can benefit from the exposure that we have because our long-term goal is a manned mission, while not having the risks which are obviously there for manned mission to Mars, because they will be there for any manned mission to Mars in any time, in any place. So these partner discussions are going very well, and combined with the good progress that we are making on getting good media partners on board, we are more confident than ever that we can make this first technology unmanned mission a reality. And we believe that making this first unmanned mission a reality is probably the most important and most difficult step of actually getting humans to Mars. With that, I would like to close. Thank you very much. And Linda will be taking the questions for us. Thank you.
Great. I see Jeff already has his hand up. I just want to mention that for any of you here or online who don't have the press kits on hand, you can email Suzanne at press@mars-one.com, where you'll have full biographies for all of our speakers today and the press release coming out about the announcement today. And I'm going to take a few questions here at the Press Club, and I would ask that you all identify yourselves by name and affiliation and limit yourself to maybe a couple questions at a time or a question and a follow-up. And at some point, Casey in the back is going to raise his hand when he has questions online. And so we'll try to keep things moving around that way. So I see Jeff Faust here in the front row, and then AFP after Jeff.
Hi, Jeff Faust of Space Review. A couple of questions for Boz. I just wanted to clarify, these contracts you're announcing today, these are study contracts for the mission. Can you explain a little bit what the timeline and deliverables for those are, as opposed to actual contracts to build the hardware? And then related question.
Can I answer that first?
Sure.
So you're right, these are mission concept studies, both for SSTL and for Lockheed Martin. We think that they will be finished before half 2014, And after that, we will take the next steps with those companies, as is the case with most space missions that are implemented.
And then, do you have a budget in mind for these missions? How much are these missions going to cost, and what are your plans to raise the money to pay for them?
The cost of the Mars lander and the communication satellite will be a part of the study that the companies are doing. Of course, we have a ballpark figure in mind, but that's not something that I will share here in this room. As I said, we're having really good discussions with partners, especially since we have the university payload competition and the STEM challenges that we can organize. Because there's a lot of companies that are very interested in associating themselves with that. Our most concrete discussions are around the university payload competition. There's a lot of companies that are looking for good engineers. And there's a couple of really big companies that have a really hard time finding them. And this is for them a perfect way to get in touch with engineers all over the world. Of course, they will be a financial sponsor to our mission, so they will get something in return, which will be contact with the students that participate in these challenges. So when we send information packages to the students, their logos, for instance, will be on the material. There will be events where the partners can also participate. And we find that these kinds of partnerships are making it a lot easier to talk to partners and sponsors than the overall manned mission to Mars.
Okay.
Thanks, Jeff.
AFP?
Yeah, Robert McPherson from AFP. Two questions. One, I wanted to ask how the recruiting of the astronauts is going. But secondly, to follow up the previous question, just for more clarity, I mean, Bas, you said at the outset that Lockheed Martin will build our first Mars landing device, and but now we're talking about mission feasibility, mission concept studies. I mean, is Lockheed like bound to eventually build the actual lander? I mean, can the board of directors pull the plug on it and say, sorry, we're not in this anymore? I mean, can I actually say correctly that Lockheed Martin will build the lander, or are we still at the too early stage then? And don't forget the recruiting question.
I wrote it down. So we promised our applicants that we would let them know before the end of 2013 if they pass on to round number 2 or not, and that's still our plan. So we're well ahead in processing all the applicants. What do you mean?
How many applicants?
We have received more than 200,000 applications when we closed the application procedure by the end of August 2013. So they will know before the end of this year if they pass or not. And I think I'll hand the second question to you.
Let me frame the path forward in terms of the suitability of Phoenix to meet the 2018 robotic mission. It's a very good match for what the payload elements are that we're considering. All right, so it's a proven delivery system. The technologies have been demonstrated. The team is in place. So there's very few impediments that one would see to continuing on to beyond the study concept to proceed with actually building the lander for 2018. Having said that, we're currently only under contract for the concept study, which is typical. Right, the typical approach is you do a phase A study, you rough in the parameters, you make some decisions about, in this case we have an orbiter and a lander, so what's the launch configuration opportunities, how much separation at arrival between the orbiter and the lander do we want in terms of days or weeks. The preferred approach would be to have the orbiter on station ready to communicate when the lander arrives. So those are all the things that you have to study in the mission architecture to come up with the right sweet spot, if you will, for putting the mission together. So having said that, then what you typically find is that the result of the concept definition phase, then you enter into the next phase for preliminary design. So that's the point where contractually two organizations bind themselves to go forward. So from my perspective, it's, there's a lot of positives and that would tell me that it's a high probability that the study is going to result in a concept that will have the ability to go forward.
And I would like to add to that of course Lockheed Martin is the most experienced company in landing payloads on Mars. Lockheed Martin has been involved in nearly every NASA mission to Mars. So for Mars One, there's really no alternative if you want to organize a very let me put it differently. If you want to organize a as low risk as possible mission to Mars, then Lockheed Martin is the most logical partner.
Any other questions in the room? Frank, Aviation Week.
Hi, I'm Frank Mooring with Aviation Week. First, a question for you, Ed, I think, or maybe Bas, is there a contract amount for these study contracts?
Yes, Lockheed Martin's, the study that Lockheed Martin's doing for us is just over $250,000 US, and the contract for Surrey is 60,000 euros.
Thank you. And for Ed, beyond it sounds like you've got a single launcher concept. Do you have a location where you would like to land, or is that still in study? I'm just trying to find out sort of the bounds of your study, where beyond just a single launcher, what you're looking at, and also the launch class, if you know that yet.
Yeah, sure. I'll be happy to articulate some of that. The single launcher, from a pure cost perspective, is probably the least expensive option. It may or may not give us the type of separation between orbiter and lander arrival that we're looking for. So I wouldn't consider that to be a done deal yet, but that's probably a preferred approach if we could work that out. In terms of where we'd like to be at the planet, if you think longer term to where Mars One wants to go, you want to be at a location where you've got reasonable access to water, and that means that going somewhere in the range of 40 degrees north latitude is where we'd like to be. All right, now, having said that, for the demonstration mission, technology demonstration, we need to balance the latitude objectives with the available solar energy and then the power and thermal control requirements of the payload, the technology demonstration payload that we're carrying. So those are the things that we have to trade to decide where does that sweet spot look like. The farther north you go, if you pick your season of arrival well, it gives you more power, but it's short-lived, that amount of solar energy. So trading that against a longer mission duration would tend to bias one more equatorial. So what we really have to look at is how much power can we get out of the thin film solar experiment. How much power do the instruments need? Where in the lifetime on the surface does the power peak for the payload experiments? You put all that in the hopper, and you come out with the results from the concept study.
And if I could ask the same question of Sir Martin, particularly with regard to the size of the spacecraft that you're planning, and any particular new challenges, thermal power, et cetera, from operating in a geostationary location at Mars.
Yeah, well, I mean, part of the whole idea of the concept study is to do the scaling on all these factors, because we need to work very closely in conjunction with our colleagues at Lockheed Martin, not just in scaling the spacecraft, but making sure that the combination together are suitable for whichever launcher is eventually provided. The new challenge is, well, it's interesting because in some ways it is a difficult challenge, and in other ways it's actually sometimes almost a little bit easier than some of the Earth type orbiters. So we're clearly going to have the link budget elements of the mission to look at very carefully. What sort of ground segment and so forth we're going to need to support this. As well as the spacecraft design. The radiation environment is throughout the transit periods and so forth are going to be something we'd obviously examine in pretty close detail. We've got quite a lot of experience of operating in high radiation orbits in the navigation systems, which are operating in GPS-like orbits. for long periods of time. We don't see that as something that's going to be necessarily a very critical element. So it's going to be just looking at the whole system together with our colleagues in Lockheed, looking at the lander, the launcher, and making sure that, as has just been said, everything adds up to give us the right solution.
Great. I want to mention again for those of you participating online that we can take questions from you at press@mars-1.com. And I think I see Casey raising his hand. Casey in the back of the room is going to read out questions from our online audience, and our panel will answer them.
Okay, question from Peter King, CBS News Radio. Is the majority of the funding for this coming from public contributions?
No, it's our expectation at this moment that the majority of the funding for our two unmanned 2018 missions will come from partners and sponsors. The public contributions are very important to us, but more so from a audience engagement point of view. We really want to make people feel that this is. I said it in the crowdfunding video. This is your mission to Mars. You can fly to Mars. You can send something to Mars. You can send a pass photo to Mars with a message for the astronauts on the back of the pass photo. We really want to get people into Mars exploration and make it something that people can believe in again.
Any other questions in the room? All questions answered. Frank, you have another question?
I was just wondering about the water experiment. Do you have a process at this one? For example, are you getting it from the atmosphere or the ground? It's in situ, but there's a lot of different ways to do that.
It will be a ground. It will come from the ground. We will open up a call for proposals for people to propose a good way of doing that. We'll have a Phoenix-like scoop on the lander, so we'll have access to the soil. But the exact design will be determined by the proposal. So we're going to look for the proposal that has the best trade-off between power, mass, and other important parameters to come up with a very good experiment.
Space.com.
Hi, I'm Tanya Lewis from Space.com. So my question is for Ed. I was wondering if you could elaborate a little bit more on how this lander will differ from Phoenix and some of the other landers that Lockheed has worked on. And then also, I guess, with these newer experiments, like the water experiment, is there a science team that's going to be, working on interpreting those results or managing those experiments, basically?
Okay, in terms of how the 2018 lander will differ from Phoenix, short background, the Phoenix landing system was originally designed for an equatorial landing site. We eventually retargeted it for the northern plains of Mars. There's another derivative, InSight, that's in development right now, that is being, the capabilities are being extended from Phoenix for a long duration Mars year type of life on the surface. So you take those factors together and it points to a landing system that is reasonably flexible with where you want to send it to the planet and the type of payload that you want to put on the lander. So having said that, if you were to look at what I think a picture of the Mars 18 Mars 1 lander is going to look like, to an untrained eye, you probably wouldn't notice any difference between a three-legged landing system for 2018 versus Phoenix. The internal guts of it will certainly have changes. Technology continues to evolve. The flight computers, for example, without going into too much detail, have evolved from a RAD 6000 based architecture to a RAD 750 architecture. So the avionics and the flight computer continue to evolve just like all of our smartphones. You got to have current technology. Software development continues to evolve. So those are the inner workings of it that if you look at the progression of missions that extend capabilities and lower power consumption and things like that. So, in terms of when all is said and done, how similar is it going to be? It's going to be very similar. There's obvious engineering things you have to look at with supply chain, availability, obsolescence, and things like that. But fundamentally, it should look very, very similar to Phoenix.
Yeah, except the thin film solar experiment, which might be a big visual difference between the two missions.
Yeah, if you look at some of the artist concepts of the 2018 lander, it has the two circular solar arrays on it, and then there's a thin film ramp, that type of appendage. So one of our design optimization studies needs to look at that thin film solar array. What's the aspect ratio of it? What's the optimal pitch that we want to get relative to the solar angle? So we can control azimuth on landing. Phoenix, its design was to control the azimuth clocking within 5 degrees. So we can land it pretty precisely in terms of where the solar angle is going to be. So those are the type of things we'll have to look at to see actually what the dimensional area of the thin film array is going to be, like how we want to deploy it. Presumably we want it to be pitched towards sun to give us a more normal incidence from solar radiation. But those are all the type of things that make engineering fun.
Casey, do we have another question online?
Baz, would you mind just
Follow up.
addressing just the question about the science experiments and who's going to be sort of, operating those, and supporting those?
So it's more a technology demonstration mission than a science mission, but of course, when you're there, you want to get as much science information also as possible. So while the water extraction experiment is going to be mostly an engineering demonstration experiment, it's also, of course, we'll try to do as many interesting things with the water as possible to see what's in the liquid water. Is it just H2O, or are there other elements in there? But the highest priority is to actually have liquid water on Mars. Our manned systems will have separate life support systems that will purify water. So the water doesn't need to be completely drinkable from this experiment. But we'll certainly have some science there. And then there's the university and the high school experiment. These could be science experiments. We're also very interested in having more fun experiments. So for instance, one of the things that I would really like to see is a balloon with a camera attached to it that will, that's tethered to the lander, that will film Mars from 200 meters or 500 meters altitude. That's never been done before, and will be very interesting to see those images. It's not fully decided yet, but it's likely that these experiments will be controlled from the Lockheed Martin control center in Denver.
Any questions online?
Yes. By the way, the questions online are flooding in, so you let me know when you want me to stop.
All right.
All right. Rory Ivanov asks a couple questions here. The first, what is the longer-term plan for Mars colonization? If the first 4 colonists make it, how soon after do you plan to launch more colonists, and at what intervals?
Yeah, I would really like to keep the questions as much as possible to our unmanned landers, but of course I'm very happy to answer this one. So Mars One wants to land the first humans in 2025, and it's our plan to send additional crews every 2 years. So on every opportunity, the orbits, the Mars and Earth orbit the planet, orbit the Sun in such a way that you can only send things once every 26 months. So we would really like to send crews there every 26 months. At this moment, we envision crews of 4, but we hope, of course, that in the future there will be bigger launch vehicles available that will allow sending bigger crews and bigger systems to Mars.
Okay. Thank you. Michael Belfiore from Popular Mechanics asks to Sir Martin, did I hear you say that in some ways the Mars orbiter will be easier to build and operate than Earth orbit systems you've worked on? And can you say a bit more about that?
Yeah, actually, I was thinking at the time that we've been doing some work on lunar comms orbiters, and it was really comparing the lunar comms orbiters to the Mars comms orbiters. the gravity field of the moon is not an easy one to navigate. And so it was really comparing the work that we've done on what was called our Moonlight mission, which was a combination of lunar communications orbiter and high-speed penetrators to land on the surface of the moon. And when we look at the maneuvers that we need to do for that compared to Mars, actually Mars is a little bit simpler. Not much, but just a little bit.
Next question. Casey's working on it.
Okay, another one. Marcia Smith, what sponsors and partners are you looking for? Philanthropists, companies, governments?
Well, Mars One is actually looking at a whole range of different funding scenarios, and philanthropists is definitely one of them. The total estimated budget for getting the first 4 humans on Mars is about $6 billion, and there's 200 people on this planet that have more than $6 billion as their personal wealth. So that's definitely an interesting path that we are very interested to explore. We have, of course, when we land humans on Mars, we will have the most unique video footage available in the solar system, I should say. And that's definitely has a lot of value if you know that the Olympic Games are worth about $4 billion for every Olympics that's organized in broadcasting rights and sponsorships. Then you can see that a human mission to Mars is definitely going to have a lot of value. And then there's the partnerships that we're looking at. I think that partnerships will be especially important for this first unmanned mission, and because it's, as I already explained, it's so concrete that for partners this is something that they can very seriously consider without the overall risks that come with a human mission.
Another question from AFP in the room?
Buzz, how much money have you managed to scrape up so far in this project? We don't disclose how much money we've secured from partners and sponsors. You can find a donation table on our website, and people from about 80 different countries have donated just over $200,000 at this moment, I believe. But of course, the majority of the funds is really going to come from partners that are interested in sending something to Mars, like the university payload competition.
Next question online, Casey?
Ken Kremer from Universe Today. For Ed, is there sufficient time to select, develop, and design the new experiments?
Okay, I'll answer the question in 2 parts. A typical life cycle for a Mars program provides for around 3.5 years from commitment to initiate preliminary design to launch. All right, so if you project what the 2018 launch period looks like, that gives us approximately 1 year from where we are today to commit to preliminary design. So we've got a 3 to 4 month time period here to do the concept studies, and while that's going on in parallel, the selection of the science and demonstration package, that suite of payload elements that we want to carry with us. So the nominal timeline that we are used to working with is pretty favorable. Now, the actual question that was asked was is there enough time to develop the science side of this? And so that's a little trickier because it's going to depend on what's actually selected and the maturity of those elements that are selected. So that's where we will be working with Boz and his team to help provide input on where we see the development risks to help guide some of the selections so that we can keep ourselves in the box, if you will, from a development timeline perspective to make sure that we do in fact select a set of experiments that have a high probability of being ready for us for the 2018 launch window.
Frank Mooring?
This one's also for Buzz, I think. The same question that I asked about the in-situ resource for the solar panel, the thin film, is that something that you already have in sight, or is that also an experiment that you're looking for proposals? And what are you looking for exactly, and how did you intend to use that as you go into your human missions?
Yeah, we'll be opening a call for proposals for the solar experiment also, so it's open for anyone to submit a proposal to. In the concept artist drawings of our mission, you can see a very big panel that's been deployed by inflatable tubes on the side of the panel. This is just our first artist impression of what it will be. Depending on the trade-offs that will come from Lockheed Martin on how much mass budget we actually have available. It might be bigger, it might be smaller, it might be a lot smaller. And so we will have to wait for those results before we can open that call for proposals for the solar panel. But we hope, of course, it will be an as large as possible panel, because additional power on the spacecraft will prolong the lifetime and will prolong the capabilities. And is also a very important demonstrator for our manned mission, because Mars One does not want to depend its human mission on nuclear, and then solar is the only readily available power source that you can use on Mars. So it's a very important experiment for us, and it's a high priority for the mission.
Great. It's 11:22 a.m. here in Washington by my iPad clock, and we're going to wrap up at 11:30. And we'll see if we can take a few more questions from the web. And Suzanne, please correct me if this is not correct. But I'm presuming that any follow-up questions or questions that are not answered by 11:30 can be submitted to press@mars-one.com, and they eventually will be answered. Suzanne will be dealing with a tweet up later today, but all of the speakers up here at the table will be available for a little bit after we wrap up. We need to close at 11:30 because some people have other places to be. So let's take another question from online.
Ryan Ziolko, it's been noted that director-producer James Cameron pushed for a 3D HD cinema camera to flow on MSL, but it wasn't ready in time. Has there been any talk with him or others in Hollywood for landing an HD camera?
Short answer, no. Long answer, the camera is one of the other things that we're still looking for a good supplier. There are some good space camera suppliers, and those are the most logical suspects for that. But we're very open to find good ways of getting cameras that can have more performance on our lander. It has to fit in our mass and power and data requirements or budgets. But that's certainly a very exciting thing, because a part of this, a very important aspect of this mission is audience involvement, and a camera that can do more will achieve that. So definitely open for things like that for our camera.
Next question from online.
Another one from Ken Kremer for Ed. Water ice is near the North Polar region, like the Phoenix site. So does that significantly limit the location and lifetime?
The short answer to that one is no. We have large latitude bands that have access to water. The question is, how long will it take us to complete the water extraction experiment? Right. So the higher the concentration is, where Phoenix landed was essentially a dirty glacier that we landed on, and the subsurface ice was within about 4 inches of the surface. Right. So that would suggest that I think the remote sensing data tells us that there's the equivalent of about 2 Lake Michigan's worth of water bound up in the first meter of depth near the north cap, polar cap, right? So we don't want to go that far north, but the imagery data that we have and the continued reconnaissance that we have from the MRO, Mars Reconnaissance Orbiter, and Mars Odyssey continue to find more sources of water elsewhere on the surface. So one of the challenges for us is to find that sweet spot that I mentioned earlier about where can we get reasonable access to water and in a concentration that will allow the water extraction experiment to complete sooner rather than later. So that's going to be one of the more important demonstrations, and we'd like to find a site where we've got a reasonable projection of completing that water extraction experiment within the first 30 to 60 days or so, if you will, on the surface. And so with that in mind, I think we've got some viable options.
Next question from online? No more questions online. Any more in the room?
Hi, my name is Aaron Hom. I'm a Mars One applicant, and my question is: in the last couple of months, I think I recall you, boss, saying something about being in talks with a particular high net worth individual. I was just wondering if those talks had continued to move forward with that person.
I can't disclose any contracts that are not signed yet, so I can't comment on that. Thank you.
Great. Well, I think we'll wrap it up now. Does anyone here at the table have a last few words to say before we close?
Yeah, well, I would really like to thank everybody for being here, for everybody that has been watching online. It's for us, this is a really exciting time. Step by step, we're moving closer to our final destination. It's going to be a long road. It's going to be a difficult and bumpy road. But I am very confident that step by step and with help from a lot of people around the world, we will finally make it. So thanks a lot, and hope to see you next time.
And I thank everyone in the room for coming out on a snowy day when you didn't really have to. And for those online, for those of you who got up early or stayed up late, wherever you are, thanks for participating.